If you haven't done so already, please take out your science interactive notebooks. Be sure to copy down any information that we say to copy down or any important vocabulary. Today's topic is called the mystery package. I'll write this down on the board, and be sure to write this down on the top of your paper. So let's start being scientists. So where does science happen?
A lab in a school.
That's good. And where do you think scientists go to do their work?
University, the desert or rainforest.
That's good. So scientists from this university go all over the world to do their work. Some go to the Arctic, while others explore the rainforest, and some even go to the oceans to explore tiny microscopic organisms. So science is all over the world, and scientists need to go all over the world to do their research. The first thing that scientists do is they make observations. Observations are used to determine properties of an object. So today, we're going to be using our senses to make observations. Mr. Mario and I will pass out these envelopes labeled A, B, and C. And we want you to write down in your student interactive notebooks A, B, and C, and write down your observations that you make on each envelope. We'll regroup in about a minute or two after you use your senses like touch, and sight, and smell. Maybe you can hear what the objects are inside without opening the envelopes. Again.
Horns.
So, what did you observe for envelope A?
It's like a long pencil type thing.
That's good. That's great observations because an envelope A had a pencil and a pen. What did you observe for envelope B?
It was a small spherical object.
That's a good observation as well because in envelope B, we had 4 different marbles. And what did you observe for envelope C?
It seemed to be a bigger object. At points where I touched it, it was like soft, and then other times it was hard. So
That's awesome. Good observations. What senses did you use to make that observation?
touch.
Good. Well, in envelope C, we had sunglasses. So I brought something else for you today. We have a package today from the university. It's from ISSMP. The UT post office didn't recognize where this was from, so they called the police and they sent in a canine unit to determine whether this was dangerous or not. The canine unit discovered that there was no explosive materials in the package. So then the package was sent to the chemical research lab, and they determined that there was nothing deadly or toxic in the package. So we brought the package for you today because we determined that it's safe to use, and we need your help to figure out what's inside. Mr. Mario is going to open the package.
Ooh, guys, let's find out what's inside this package. Oh, wow. We have a vial. So from where you're sitting at, what can you tell me about this vial?
Colorful?
Yeah, there's different colors. Can you tell like how anything smells or what it feels like yet?
No.
No, but so far we're going to use, moving on, we're going to use this vial to answer our question of the day. So I'm going to go ahead and write down the question on the board, but remember, using the vial, as we move on through our lesson, we're going to be able to answer the question of the day. So our question of the day is, how can we identify substances in a mixture? Okay guys, so go ahead and make sure you write down the question of the day on your notebooks. So, I'm going to go ahead and put up a list of physical properties on the dot can. So now that everyone can see the list of physical properties on the dot cam, remember, scientists, when they're doing observations and studies and experiments, a couple of things that they do is observe the objects or the experiment using this list of physical properties. So remember, make sure whenever we're going out throughout the experiment, if you need help remembering what are different kinds of physical properties, you'll have a list to refer to. So moving on from there, Miss Sam is going to pass out a mystery package vocabulary sheet, in which whenever I bring up a very important vocabulary word, or Miss Sam, you will go ahead and write it down. So you can make sure you know what that means, and you're going to be able to use those words throughout the experiment. So to start off with, a mixture is when two or more substances are combined and the chemical makeup does not change when they are combined. So, what is a mixture?
Two or more substances.
Okay.
And their makeup chemical does not change.
Ah, so it stays the same, right? And how many substances did you say we need to make a mixture?
Two or more.
Exactly. So you can either have two or you can have plenty or more just to make a mixture. So make sure to write down mixture on your first vocabulary word. Okay, so now that everyone's written down mixture, we're going to go ahead and turn around the worksheet, your vocabulary sheet, and you're going to have a mystery package observation sheet. But before we move on to there, we're going to have to talk a little bit about lab safety. So, with the lab safety, now we have determined that what's inside the vial, it is safe. So that means we can go ahead and touch it and smell it to make a couple of observations. So, how would you smell the substance?
Maybe put it out in front of me?
That's a good guess, but we have a special technique that we use when we're smelling the substances that we're trying to do the experiment with. So what you would do is, when doing the experiment, we're gonna pour out the substances into these containers. And what you would do is, either with the spoon or by picking up the container, you would put it not directly in front of you, and you would, with a motion waving towards you, you would smell it. And the name of this technique is called wafting. What was the name of this technique?
Wafting.
And how do you do it?
You put it out in front of you and then wave your hand towards you.
And then you would be able to smell it, right?
Mm-hmm.
So, hey, can I taste it? Because that would be a physical property, right? Taste?
No.
No. Do you know why we can't taste it?
Scientists don't taste things.
Exactly. They never taste any of their materials or substances. It is, even though we said it was safe, it still might be dangerous to taste it. So, what kind of physical properties are we going to look for?
Using our senses?
Using our senses, but which ones? Which physical properties which senses can you use to determine physical properties?
Sight.
Sight. And like I said, we can touch it. So what physical property would you figure out by touching?
Touch.
With touch.
Like soft.
How soft. And that would be called like texture. So now moving on, what we will do is Miss Sam is going to go ahead and pass out the materials to everyone, and we will go ahead and do the first layer together. And then I will go ahead and let you do the rest on your own. So before we actually go ahead and start, look at your observation sheet. And there is a column called physical properties. There, and you have different layers numbered, so you will write down physical properties for each layer. Before moving on to each layer, make sure when you do one layer, write down physical properties and then move on to the next. So this is how we will go ahead and do it. So to begin with, we will safely open our vial and remove the top and set it down. Some of y'all might have a piece of cotton on the first layer, so make sure to remove the piece of cotton if it is not stuck on your cap. You will either use your fingers or this paper clip to help you take out the piece of cotton. So can anyone tell me why that piece of cotton was there?
To divide the substances.
The different substances or layers. So you don't want it to mix up with all the other layers. So that's why that piece of cotton is there. So now that it is safely open and the cotton has been removed, you will go ahead and pour out the first layer into one of the containers. The containers will be labeled 1, 2, 3, 4, and 5, so that students will keep track of which layer is which. So pour the first layer into the first container. Make sure you try not to spill any of it, and make sure you get as much of it as you can out of here. So now that you finish pouring the first layer, before you start any observations, make sure to close your vial. Secure it tightly to make sure none of the substances fall out. And go ahead and place it down now that the vial is safely secured. So moving on from there, you will go ahead and make your first observations for the first layer. So go ahead and take a second and with your group, write down any physical properties that you see for the first layer. But before you start, where will you write down these physical properties?
In the first column.
The first column, right beside layer 1. Okay, so go ahead and take a minute. And so, what observations have you made on the first layer?
That it's white.
It's white, that's true. How did it feel?
Soft.
Kind of soft, okay. Did it have any scent to it?
Mm-mm.
No, it didn't smell like anything? Okay.
Nope.
So now that we're done with the first layer, everyone will go ahead and do the rest of the layers by yourself. And once you're done, we will go ahead and talk about the next column, but do not move on until everyone is ready to proceed. So make sure you write down some good observations before we move on. Okay, so guys, before moving on to the next layer, there will be a piece of cotton there. So make sure either with your fingers or the paper clip to remove it. So now that the piece of cotton is out and you set it on the paper plate, you will be able to pour out the second layer onto the second container. So go ahead and safely pour out the second layer or substance into the second container. Make sure you get as much of it as you can out of it. And then go ahead and close the vial, secure it tightly, and set it down on your paper plate. So, go ahead and take a minute to make the observations. So, what can you tell me about the second layer?
That it's brown.
It's brown. Is it a dark brown? Is it a light brown?
Light brown.
Light brown, okay. Is it hard? Is it soft?
It feels rough.
It feels kind of rough? Okay. Yeah, it does feel rough. Did it smell like anything? No? Okay. Another layer that didn't smell like anything. Did anyone taste it?
No.
No. Okay. Make sure you don't taste it. So, moving on, we'll go ahead and open the vial again. Put the cap down, and using your paper clip or your fingers if you can reach, take out the next piece of cotton and set it on the paper plate. Now that the cotton is out, go ahead and pour the third layer onto the third container. now that everything is out of the vial, go ahead and close the vial and set it down. Go ahead and make some observations off your third container. Okay, class, now that we're all done making observations, I'm gonna need your attention, so hook 'em.
Horns.
All right, good job, guys. So, moving on, we already made our observations for layer 1 as a class, but what did you observe for the second layer?
That it was light brown and
Okay.
rough.
Did you smell it?
Smelled like sand.
Like sand? Well, I don't know what sand smells like, but okay, you know what sand smells like. So, what about the third layer? I thought it looked like the first layer. What do you think?
It felt rough.
It felt rough? So, do you think it looked like the first layer?
Kind of, but it looked rougher.
It looked rougher. Okay. So you made sure to write that down, right, on your observation?
Mm-hmm.
Did you smell it?
No.
No? Okay. Did you taste it?
No.
No? Okay, good job. I was just testing you there. And you passed. So, moving on to the fourth layer, what did you observe?
It's blue.
It's blue. Okay. Okay. Did it taste, did it feel rough? Was it soft?
It felt rough.
Yeah, it does feel pretty rough. Did you smell it? Did it smell like anything?
No.
No? Okay. What about this last layer? This one's like, has 3 different colors, doesn't it?
Mm-hmm.
Can you tell me what the colors were?
Like black and white and brown.
Yeah. Wow, this one's weird. It has 3 different colors. Did you touch it or anything?
Yeah, it felt a little rough and smooth.
So rough and smooth? Okay. That's weird. This one has, it felt rough and smooth. Did you smell it? That's a pretty strong smell if you ask me. See, and in class, how did I smell this?
Using wafting.
Ah, did I do a good job with the wafting?
Yes.
Oh, okay. Alright, so now that we're done making our observations for our physical properties, let's go ahead and move on to the next column. And the next column is prediction of what will happen in. Alright, class, now that we're finished making our physical properties, writing down our physical properties on the first column, we're going to go ahead and move on to the second column. So, in the second column, we're going to go ahead and make predictions of what will happen if these substances are in water. So, go ahead, we're going to go ahead and take 5 minutes, but you're going to go ahead and write predictions. Try to write some good predictions. We know that if we pour water into these substances, they will get wet. So, try to write down what will happen to it instead. Go ahead and hook them.
Horns.
Alright, thank you guys. So, now we're going to go ahead and pour water into our containers. I will go ahead and teach you how to do the first one, and then you will go ahead and do the rest on your own. So what we're going to have here is a cup full of water and a pipette. But before we go ahead and pour anything, what's going to happen is you're going to go ahead and pour water into one of the containers, and then write down your observations. But you will not be able to move on to the next layer until you are done with the current layer that you're working on. So, are you going to go ahead and pour water in all the layers?
No.
No. Why not?
You stay with the first layer.
Until you're done making observations. Okay, so we're going to go ahead and fill the pipette with water. Now that it's full, go ahead and pour the water into the container. You're going to go ahead and grab a second dose of water. Make sure it's as much as you can get with the pipette, and go ahead and pour it. You can go ahead and set down the pipette, and you will have a stick to go ahead and mix it. So go ahead with the stick, mix the container with water. And make sure you mix it very well. And once you're done mixing it, go ahead and set the stick down, and you will go ahead and make observations. You can make the observations with either the spoon or the lens, the magnifying lens. So you will want to use the spoon to go ahead and get a closer look on your material. Or you can go ahead and also use the magnifying lens to get a closer look. So guys, you have enough sticks to mix each container with its own stick. Why does each container have to have a different stick?
To make sure the substances don't mix.
Exactly. You don't want to contaminate your substance, do you?
No.
So what observation did you see for the first layer?
That the material became bigger.
It became bigger? Oh wow. So did it stay white or
It stayed white.
stay white? Okay. It's pretty cool. So now that we're done making the observations for the first layer, you will go ahead and continue this process for the rest of the layers. So how many doses of water from the pipette are you going to pour into the container?
1,
2.
2.
Remember, we're going to use 2. And am I going to use the same stick to mix all of them?
No.
No. Why not?
You don't want them to mix.
You don't want them to mix, so you will have enough sticks. So, can I make if I want to get a closer look, can I use the same spoon for all of them?
No.
No. Okay. So now, go ahead and finish making the observations. But remember, do not move on to the next layer until you're done with the layer you're working with. And make sure you write down some observations. So you'll go ahead and let the class finish pouring water. And you'll go ahead and pour some water too. So class, now that we're done, we're going to go ahead and get together again. Hook 'em.
Horns.
What did you see on the second layer? After you poured water.
It sunk to the bottom.
It sunk to the bottom. Did it change color or anything?
No.
No? Okay. It's a pretty good observation. What about the third layer? What happened to that one once you poured water in there?
Floated to the bottom.
It floated?
No. It went to the bottom.
It went to the bottom? Okay. That's interesting. What about the fourth one?
Same thing.
Same thing? Oh wow. Anything with the last one? Anything different with the last one?
No.
No? Okay. Oh wow, so they all basically the same thing happened? Okay. So, moving on from there, we're going to go ahead and talk about the substance column. So we're going to try to figure out what's each one of these based on the observations you made. So I hope you wrote down some good observations. So what's going to happen now is we have a list of substances and we list some physical properties. So I'm going to go ahead and put it on the dot count. So based on the list that you see on the dot count and the physical properties of certain substances, you're going to go ahead and identify what these substances are. So, okay class, now that we've all had enough time to identify each substance, we're going to come back together. So, hook 'em.
Horns.
Alright, so on the first layer, can you remind me what were some of these physical properties for the first layer?
That it was small and white and smooth.
Ah, okay. Did any of these properties help you identify what the substance was?
The first layer is instant snow.
It's instant snow? Oh wow. And all of this because you had the physical properties, right? So what about the second one? Remind me of the physical properties.
It was light brown and rough.
And rough. Okay.
And it's sand.
It's sand. Awesome. Got it. What about the third layer?
The third layer was white and small and rough. So I said it was salt.
It was salt? Okay. I'll buy that. What about the fourth layer?
It was colorful and small.
Okay.
So I said it was magic sand.
You said it was magic sand. Whoa. Any luck with the last one?
Yes, it's pepper.
It's pepper. Oh wow. How do you know it's pepper?
Because of the properties of pepper that were black and multicolor and small matched the list.
Oh, wow. Okay. That makes a lot of sense.
So now I am going to help with the last column. Let's see. It says to determine whether each layer is homogeneous or heterogeneous. So let's find out what this means. So, I have two vials. One is oil and water. I've dyed the water blue to help you see the separation between the oil and water. Then, I have a vial, and I'm going to put sugar in it. So, what do you observe about this first vial of oil and water?
Oh, they're separated in layers. You can tell where the water is and where the oil is.
Right. So the oil and water are separated. There's a distinct layer, and the oil is on top of the water. What do you observe about this next vial that's containing oil, that's containing water and sugar?
I think the sugar is in the bottom.
Right. So you can see that all the sugar has collected at the bottom. So turn to your partner and make a prediction about what you think will happen when I shake each vial. And when I shake them, they're going to mix together. Do you think that they're going to separate or mix evenly? Do you think they're going to start floating? Turn to your partner now and have a discussion about it. Hook 'em.
Horns.
Okay, class. So, what did you observe, or what did you predict would happen when I shook this mixture of oil and water?
I think they might mix.
That's good. And what do you think might happen when I shake this mixture of sugar and water?
I think they should also mix, but maybe some of the sugar will still be in the bottom.
Okay, so I'm going to shake them and let's see what happens.
Ooh.
Okay, let's give it a minute to settle. Okay. So, what do you observe now about the sugar and water?
The sugar and the water? It looks like they mixed.
Right, so you can see that there's not that many sugar particles anymore at the bottom. And what do you notice about the oil and water?
It's still separated.
Yes. So, let's turn to your worksheet of the vocabulary side. Now let's figure out what homozygous and heterozygous mean, because those are big words. So, homo means the same, and hetero means different. You can write these two words in your vocabulary sheet. So, I'll write this on the board as well. Homo means same. And hetero so homo means same and hetero means different. So, looking at your vocabulary sheet, which diagram do you think represents a heterozygous mixture?
The first one.
Right, so the first one you can see has two different layers. So we know that this is heterozygous. I'm going to assist you with the last column. Let's see. It says to identify the substance, whether it's a homogeneous mixture, or a heterogeneous mixture. So, those are big words. Let's find out what those mean. I have two vials, and they're examples of a homogeneous or a heterogeneous mixture. Now, in this vial, I have oil and water. And in this vial, I have water and sugar. So what do you observe about this vial?
It looks like they're in layers.
That's right. They have distinct layers of the oil's on top and the water's on bottom. I've dyed this water blue so you can see the distinct layers better. And what do you notice about this vial?
It looks like the sugar's in the bottom.
Right. So I poured sugar and it's all collected at the bottom. Now, I would like for you to turn to your partner sitting next to you and discuss for about a minute whether you think what will happen whenever I shake these two mixtures. Do you think that they're going to mix evenly or separate? Do you think they're going to stay in layers? Discuss with your partner now. Okay, cook them.
Horns.
So, I think I've given you all enough time to make predictions about what happens when I shake them. So, okay, so what do you observe in the vial containing sugar and water?
I can't see the sugar anymore.
Right, so the sugar is no longer collected in the bottom. It's been dissolved by the water. And what do you think happened here?
It looks like they mixed a little bit, but one color is still darker than the other one.
Right, so a few of the water particles have gone into the oil, but overall the layers are still distinct and the oil is still on top. So, let's look at our worksheet. Right below mixture, I've written on the board that homo means the same and hetero means different. So you can write this down in your worksheets as well. That homogeneous, is the same and hetero is different. So we know that a heterogeneous mixture is when two substances do not mix evenly. And you can write this down in your worksheet here. So, do you think that the vial of oil and water is a heterogeneous mixture or a homogeneous mixture?
I think it's a hetero.
Right, and how do you know that?
Because you can still tell which one's which.
Do you know any other examples of what a heterogeneous mixture might look like?
Maybe when you make a salad.
Right, yes. So whenever you have lots of materials or layers, or whenever an object is unevenly distributed, it means that it's a heterogeneous mixture. So, homogeneous means that two substances do mix evenly and they usually don't separate. And they cannot be separated easily. So, for a vial of sugar and water, do you think this is a heterogeneous or a homogeneous?
It'd probably be a homo since you can't see it anymore.
Right. So, it's not going to be easy to separate the sugar. But what you can do is maybe evaporate it or filter it out. What someone may try is that you could boil the water and filter out the water, and the water would then evaporate, and you'd be left behind with sugar. So, you can separate the sugar and water, which would make this homogeneous, correct? So, looking at these diagrams, the first one, do you think it's a heterogeneous mixture or a homogeneous mixture?
The first one.
Right, it's a heterogeneous mixture. And what do you think about the second diagram?
It's homo.
Right, so it's a homogeneous mixture. How did you know that?
Because they're evenly distributed.
Right. So, an example of a homogeneous mixture would also be like sugar and water. But a solution can be a homogeneous mixture. This is a solution because a substance dissolved in another substance. And right here we have that the sugar dissolved in the water. So, the last vocabulary word on your sheet is a solution is a type of homogeneous mixture where one substance dissolves in another. So, do you think that this is a chemical property or a physical property of the sugar dissolving in the water?
It's chemical. Oh wait, but it might be physical.
So, because it can dissolve, it's actually a physical property. Because the water and sugar can still be separated, like I mentioned earlier, by using a filter or maybe evaporation. It can definitely be separated and returned once again to sugar and water separately. So, because you can reverse the change that you did, because you can reverse it, it makes it a physical property. So dissolving is definitely a physical property. So let's turn back to our observation sheet worksheet. Now, go through each layer and decide whether it's homogeneous or heterogeneous. You can do this now with a partner. Okay, pick them.
Horns.
Great, so what did you say was a homogeneous mixture?
The instant snow and the salt.
That's correct. Why?
It seemed like it was evenly distributed.
That's correct. And what did you think was a heterogeneous mixture?
Both of the sands and the pepper.
That's correct. And why did you think that?
It seemed to like stay separate from the water.
That's true. So, we defined a solution as a type of homogeneous mixtures, but not all homogeneous mixtures are solutions. So, you said that the instant snow and salt were homogeneous mixtures. Do you think that they were both solutions?
No.
Which one do you think is a solution?
I think the salt is a solution, but the instant snow wasn't.
And so how did you reach that conclusion?
Well, whenever you mix the salt with the salt dissolved in the water. But when you added the water into the snow, it was absorbed. The water was absorbed.
Right, so since we defined a solution as when a substance dissolves in another substance, the salt dissolved in the water, but the instant snow absorbed the water and did not dissolve in it. That's why we're considering salt as a solution and the instant snow as just a homogeneous mixture. So, now that we've completed our lesson, let's try and answer the question of the day. How can we identify substances in a mixture? Let's answer as a class.
We observed each layer's physical properties and we figured out what they were.
Great. So, using our senses and our new knowledge and vocabulary and our making observations, we were able to identify the substances in the mixture. So, Mr. Mario has another activity planned.
Alright class, so in our vial, two of the layers got mixed up. So we separated them out of the vial and put them inside this petri dish. So we're going to go ahead and pass out the petri dish to everyone. Alright, now that every group has their own petri dish, how do you think we could separate these two substances that got mixed up?
A filter?
That's a good idea, but these substances, like if you take a close look, they look like they're the same size. So, what if we use a magnet? What do you think would happen if we use a magnet?
If it was magnetic, then it would stick to the magnet.
Ah, that is true. So, let's go ahead and try and see what would happen if we stuck a magnet to the petri dish. So, everyone, go ahead and take the magnet and put it on the bottom of the petri dish and see if anything happens. And move it around. Do you see anything happening?
Some black particles are moving and sticking to the magnet.
Oh, that is true. So what if we go ahead and keep the magnet and pour it down? What do you think will happen?
The magnet, the black stuff will stick to the magnet.
And the rest of the things will fall off, right? Oh, wow. So that means some of these things are magnetic, right?
Mm-hmm.
And how do you think this is helpful to scientists, knowing that some of these things can stick to the magnet?
They can use magnets to separate a mixture and tell the difference between the two.
Oh, wow. Since we can use the filter, the magnet would, since not both of the substances are magnetic, we can just use a magnet, right?
Right.
Okay. So, moving on from that, what physical property is this?
It's a physical property of magnetism.
Magnetism, exactly. So, remember the list that we had up there on the dot cam? I'm going to go ahead and put it up there again. And magnetism is one of our physical properties. So, let's pretend we add water to this mixture. How would you go about separating this mixture now? Go ahead and talk to your shoulder buddy for a minute and think of a way to separate this mixture if water was included. Okay guys, so let's come back together. Hook 'em.
Horns.
So what did you and your shoulder buddy talk about? What do you think would be a good way to separate this mixture with water?
We said we could use a filter to separate the iron fillings and the sand, and then we could use a magnet to separate.
Oh wow, that's a pretty good idea. So first we get rid of the water, and then we still have the two small substances together, right? And then since we know one of them is magnetic, we can use the magnet to separate it, right?
Right.
Okay, so now that we know how to separate the iron fillings from the sand, maybe what are other physical properties that we've covered today? That we talked about today?
Size.
Size. Okay, that's a good one. So, and also texture, no?
And color.
And color. Awesome. So, moving on from there, remember how we had a homogeneous mixture of salt and water? What do you think we could do to separate those two?
Evaporate it.
We can evaporate it. What if we use a magnet? You think the sand will stick to the salt will stick to the magnet?
No.
No. So that means some things are harder to separate than others. So we'll probably have to boil it or let the water evaporate. Okay. So so some substances are harder to separate from each other, like salt and water. Salt and water, you would have to let the water evaporate, or you have to boil the water so you can separate it. So now, we've covered a lot of things today. We figured out how scientists would identify substances by looking at physical properties. We were able to answer our question today: how can we identify substances in a mixture, which all of you should have answered in your notebooks. And we know what a homogeneous mixture is, or a heterogeneous mixture is. And now, to finish off, Miss Sam and I will go ahead and pass out this show what you know worksheet to every one of y'all. So we know what you know. Okay, so now that we know how to separate the iron fillings from the sand, maybe what are other physical properties that we've covered today? That we talked about today?
Size.
Size. Okay, that's a good one. So, and also texture, no?
And color.
And color. Awesome. So, moving on from there, remember how we had a homogeneous mixture of salt and water? What do you think we could do to separate those two?
Evaporate it.
We can evaporate it. What if we use a magnet? You think the sand will stick to the salt will stick to the magnet?
No.
No. So that means some things are harder to separate than others. So we'll probably have to boil it or let the water evaporate